Okay, so today we are going to cover two relatively vocab-heavy sections in the book. And so there's going to be twice today when I say you're going to want all of this. So either take a screenshot or snip it, pause the video and snip this, or I also uploaded the notes and it's on the notes all filled in for you. But look through these right now. This is one of those. I would like all 7 of these postulates to be accessible to you. They are in the notes that I uploaded, and they are also, they're in the book, they are in this video if you want to screenshot it, if you want to take a picture with your phone, but they're really important. And so the first thing I'm asking you to do is grab these in some way so that it's accessible to you, and then read through them. So pause the video, read through these, see if you can kind of make sense of each one. Okay, so grab this, and I will be quiet for a minute, pause, take a picture, do what you need to do. Okay, so I'm not going to read through these. Again, you have these. They are uploaded. They are in this video. Please, please, please read through them, but we are going to use them in this next little tiny practice portion. Okay, so there are some pictures here that we're going to look at. So we're just going to start with this number 1, and it looks like to me it says if there are 3 points, then there's a line that goes through those 3 points. So I'm thinking, what do I think this is? And so I'm looking, and there's one line that goes through all those points, and there's none that say 3 points, but there's one that says through any 2 points there exists exactly one line. And so I think that's probably the best option here. And so if you have any 2 points is going to be a line. And if there's 3 points that are collinear, there's also going to be one line that goes through them. But it doesn't matter where you draw 2 points, there's always going to be exactly one line that goes through those 2 points. So this one is an illustration of the 2-point postulate. Okay, then we're going to look at this next diagram. And I see this plane. It says if there's this plane with 3 lines on it, or 3 points on it, and then, I have a line going through that's also on the plane. So it's a line on the plane. Oh, I bet it's the plane line postulate, okay, because there's 2 points on the plane, and there's one line that goes through those 2 points. Okay, well, the only difference I see between the if picture and the then picture here is that there's a point right there. So it's going to be something about 2 lines intersecting and having 1 point. And so that's called the line intersection postulate. Because if 2 lines intersect, there's exactly 1 point of intersection. Okay, this bottom picture here, it has 2 planes intersecting, and I see that here there's a more pronounced line on the second part of this. And so if 2 planes intersect, there's 1 line. And so which postulate says that? That's the plane intersection postulate. All right, we're also going to use these postulates to decide whether we can assume the next set of statements are true. So again, have those statements or those postulates somewhere that you can access them. So planes A and B intersect at line EF. So here's line EF, and here's planes A and B, and I would say yes, we can assume that because there's 2 planes and they intersect at a line. C and D are collinear. Well, I don't even need to know where C and D are. I can say yes, because through any 2 points, or any 2 points are collinear. If there's just 2 points, they are collinear, period, end of story. You can draw a line through any 2 points. Okay? Next part is HJ and ID are perpendicular. So here's HJ, and here's ID. And there is one right angle marked right there. So the answer to this is yes, because if 2 lines intersect and there's one right angle, that means there's 4 right angles. Okay. GD is a bisector, so cuts in half, EF at point D. Okay, well, there's some really important pieces here. EF is right here. EF is marked that it's the same on both sides of point D. And GD goes through point D. So yes, it is the bisector. Okay. Next is segment IH and segment GHG are congruent or equal. And it might look that way, like IH is right here and GH or HG is right there. They look pretty similar, but there's not enough information. They're not marked. You're not 100% sure they're congruent. Okay. Last statement, we are looking at this diagram. H, J, B, and H, B, J are complementary angles. So this angle and this angle. Now, if you look, here's a triangle that's formed here. There's a right angle right here. And we know triangles have 180 degrees total if you add up all the angles. And so if we take that 90 degrees out, we have this angle and this angle. And so they add up to 90 degrees, which is the definition of complementary. So the answer there is yes, because of that triangle. Okay, so those are all the postulates, and then using diagrams to make conclusions about points, lines, and planes. Now we're going to talk about some algebraic properties. And so let's see if I can make these all fit so you can get like one picture of all of this together. Okay, so please, this is the second time that I'm going to ask you to take a screenshot, to write it down, to print out the notes, to look at the notes that I've posted. It's there, it's in this video. Take a picture with your phone, do whatever makes the most sense. But these are all properties you've seen before. These are just the names of them. So the addition property of equality is when we add the same thing to both sides. Subtraction property of equality is when we subtract the same thing from both sides of an equation. Multiplication, multiply both sides of an equation. Division, divide both sides of an equation. And substitution is when we put something in something else's place. Okay, and we have to do it across the whole equation. And then this last part is the distributive property. And so if you remember, if there's a number in front of the parentheses, we're multiplying everything inside of the parentheses by that number. Okay, and so these things that are in bold here, this part, and the distributive property, we're going to start writing some proofs. And so those are super important pieces of writing proofs, okay, is being able to say the why, to justify your steps. Okay, so here's some more whys. These ones will be new to you, so definitely make sure you have a picture of this as well. Okay, so the reflexive property is just saying that there's the same thing on both sides of an equation. Okay, exactly the same on both sides, exactly the same segment lengths, numbers, angle measures, exactly the same. Okay, symmetric property is just saying that we can flip the order of an equation. So we can say A equals B is the same as B equals A. And then the transitive property is if A equals B and B equals C, then A equals C. So if you think back to earlier last week when we were talking about the law of syllogism and the law of detachment, this is like when you cancel out the middle parts and use the if and the then statement, or the hypothesis and the conclusion, and put them together. And so it's when the entire side of an equation cancels out, and then you can put these two other pieces together. So again, the entire side, and then you put the other two pieces together. Okay? So we're going to use these, and these equations are solved here, and really what we're doing is we're writing down the justifications, our algebraic reasons. Why is it okay to do each of these steps? So the first step is looking, okay, I'm given this, and that's almost always going to be your first reason, given the equation. But to get from here to here, what's happening? So I see that there's 12 being added to each side. Okay, so we call that the addition property of equality. And I do want you to write that there, but you can abbreviate it as POE. And then from step 2 to 3, I see that they're taking an x away from both sides. So that is the subtraction property of equality. And then from here to here, we're dividing by 4. And so that is the division property of equality. Okay. What I would love for you to do right now is to pause the video and try to figure out what these steps would be using those words that we just went over. So pause the video and see if you can come up with the 3 blanks that go with this equation. Okay, hopefully you were able to see that this first step is from here to here. They're using the distributive property to simplify the left side of the equation. And then from here to here, subtracted 4x from both sides, so that's subtraction. And then from here to here, added 5 to both sides to get x equals 18, and so that's the addition property of equality. Okay, now we're going to solve the equation for the variable, and we're going to justify each step. And I'm just going to go through this with you today, but our goal here is to eventually be able to write the steps and each reason. So we want to solve this equation, c equals 2 pi r for r. That's what we're solving for. And so to get r by itself, we need to get rid of the 2 pi in front of it. And so what we can do is divide both sides of our equation by 2 pi. And so we get c over 2 pi equals r. And so our justification here, or our reason, would be division property of equality. Okay, and the reason we have this crazy equation with a c and a 2 and a pi, and because that's an actual formula for the circumference of a circle. Okay, and so this is when that would be helpful is, hey, I have the circumference, but I want to find the radius. And so now, if I solve it for r, I have that new formula. And so that's why we would manipulate this equation. Okay, we're going to solve this other one. It's surface area, and it's pi r s plus pi r squared. Okay, so we are going to solve it for s. So the first thing is we want to get this term with an s isolated. So we're going to subtract pi r squared from both sides. Okay, and then we get a minus pi r squared equals pi r s. We want to get s by itself, so we're going to divide by pi r. So this ugliness right here is what s is equal to. And so again, we need to justify our steps. Well, I even have the subtraction here. So this first justification would be the subtraction property of equality. And then from here to here I divided again, so that's the division property of equality. So really when we're writing proofs, what we're doing is we're just justifying our steps with words. We're explaining what we're doing. Okay, pause the video. Try and match each of these with the property that it goes with. So look back at those properties, those pictures that you took, and see if you can come up with the right answers. So pause. Okay, check your answers here, see if you agree. I want to just talk about transitive here at the bottom. Remember, it's because we're canceling out entire sides of equations, okay, and statements, and having this whole thing and this whole thing being equal at the end. Please let me know if you have questions. Otherwise, I will see you in a day or so.